Okay, so we're doing 2.3 volumes of a revolution. In this section, we have a cylindrical shells. So this is one of the methods to find the volume in Calculus 2, right? So we had the disk method and the washer, and this is the third one, is a cylindrical shell. I mean, before we had cross section, which is the same as the disk section, disk method. All right. So cylindrical shells is pretty easy, easier than the washer. Okay. But then we have to understand the concept. All right. So I wanted to start. We have a rectangle under the curve, right? So this is a function. Then look, we have around the rotating y-axis. This one rotating y-axis. Can you see that? Y-axis? Then they generate the cylinder like this, like this, not like this, okay? So we call this is cylindrical shells. Cylindrical shells. Okay, look, they have more shells. You can see that 1, 2, 3, 4, 5, 6, right? Okay, so now I want to derive this formula. Okay, let me bring the another picture because I'm not good in the drawing. I'm trying. All right, so this is cut. We call this is a cylindrical shell. Okay, now probably I want to do next page. Next page. Okay, let me cut the other one later on since we don't have time. All right, so volume of shells. Then look, we will have volume of cylinder. Okay, and look outside the cylinder. There is a cylinder, right? And subtract to volume of hole inside. Okay, so the cylinder is outside and then hole is inside here. Hole, right? Okay. You can see that, right? So one is a hole there, one is a cylinder outside. Yeah. All right, then I label the R radius between here to here, the big R, because from here to here. Okay, so uppercase of R, I'm using it, and lowercase inside the hole, start here to the small r, which is a small radius. I denote like a lowercase of r. Okay, now then we can say that we have a table, right? So let me denote it this way: pi, the uppercase of r h, I'm sorry, r squared h minus, this will be the pi small, the lowercase of r squared h. All right. That is the volume of a shell, cylinder, and volume of a hole. All right, then look. Since they have a pi and h is common, so I want to factor out. That is the uppercase of r squared, which is big R radius, minus small r squared, right? Now, okay, then we have this what is called? Oh. No. So we have difference of squared, right? So there is a minus b and a plus b, right? Okay. Now, so I want to use here r square minus uppercase r square minus small lowercase of r square, which is, let me just write down because it's hard to tell, right? R plus r, right? Okay, by following the formula. All right, then, I want to, using the technique, what kind of technique? I want to use multiply by 1. Okay, so what kind of multiply by 1 I want to use? All right, so before I do that, I want to make this way. Just arrange the order. Then H and R minus R, right? See, I just arranged the order. That's it. Then I want to multiply by 1. Which one? I want to multiply by 2 over 2. So here is 2 and 1 over 2. Technically, we did something. Literally, we did not do anything because of multiply by 1, right? Okay, now we have, this is a 2 pi. And look, the large R, the radius, and we add a small radius and divide by 2. This is average of radius, right? So let me write down. This is average of radius. And look, H. So we stands for H as a height. Yeah. Okay, height. So it's a height there. Now we have, I showed you at first the big radius and small radius, right? So this will be a thickness. So this one minus this one, right? Then this will be thickness here. Can you see that? One more time. This one minus that one, and we get the shell part, right? Okay. All right. So let me write down thickness. Okay, then we can derive the formula. So formula has, let me see. Cylindrical shell. Let me write down cylindrical method of cylindrical shells. So look, we have average of radius, and we have a height, we have a thickness, right? So we denote this one. We have to understand cylindrical shells. Then computational is much, much easier. So we have the function continuous, and then R be the region, right? Then X has interval A to B, okay? But then in this case, everything is I said X, right? So this is a special, so let me write down. FB continuous and also non-negative. Then X is between A and B. Okay, everything I said X, right? But then it's revolving about Y-axis, okay? And the volume of the solid of revolution formed revolving or around y-axis by, can you see that? Y-axis. So we have the volume from A to B, and we're gonna have the 2 pi. So that's how we get here 2 pi. Now average of thickness we're gonna use as x. Okay, and we're gonna use the height is the function, right? We are using the function, which is f of x in this case. Now thickness we are using as dx. Okay, so let me rewrite for you. So think revolving y-axis. So we think creating the solid revolution, huh? So creating the cylinder, x-axis, the shell. How about just to make shells in x-axis? X interval, how about that? X interval. Because y-axis, x-axis is a little bit confusing, okay? All right, so think in this case, x is the average of radius, and this is the height, this is the thickness, right? So you guys understand? So actually, the solid of revolution revolving y-axis, the thickness generating the thickness, creating the thickness in x interval. Can you imagine that? Can you see that? So it's like this one. Okay, so you guys okay with this one?
Yeah.
Excellent. All right. As long as you understand this one, then computational, everything is easier. Okay. All right. So first problem, let us do that. So we have number one, because I want to save the time for the writing. Okay. So number one problem, this is from your book. We have f of x, come on. F of x equal to 1 over x, right? And then let's see, this one below by x-axis over interval 1, 2, 3. So everything in terms of x, but then look, they said the solid of a revolution formed by around y-axis. So y-axis, okay, rotating, then we create the thickness about the x-axis, x interval, right? So let me write down here. So think thickness, I see, thickness, what did I say, shells, thickness. Thickness. Think the around, hey, listen to me, around, okay, listen now. Good boy. Okay, around the y-axis means creating the thickness in x interval, okay? All right, that means integrate with respect to x. All right? Okay. Then everything, the variable must be in x, right? Look, we set it up. The volume, the interval is given 1, 2, 3. Can you see that here? 1, 2, 3. So we're gonna use that 1, 2, 3. Now 2 pi. The thickness, I'm sorry, the radius, and then function will be the height, which is 1 over x. And the thickness, which is dx, right? Okay. Let me check. Then the integration is easy, right? So we have 2 pi and simplify, right? Then what do you get? From 1 to 3, we have a dx.
It's just x, right?
Just x, so x alone. So 2 pi, just the x squared from 1 to 3. So we evaluate. Now 2 pi, 3 minus 1. So what do you get?
4 pi.
4 pi. Very
4
good.
pi.
Yeah. See. Cube root every minute. So integration part is easy, right? Okay, now we do second problem. So this problem, okay? So you should read. This is also, look, we have a function, arbitrary result from 0 to 2 and find the volume and around the y-axis, okay? So very similar with the first one, right? Okay, so the volume from 0 to 2. And 2 pi radius, which is x. Let me see. The thickness, let me write down. Around the y-axis means rotating, right? Rotating y-axis. Then think creating the thickness. In x-axis, x interval. Means that integrate respect to x. Okay, so everything we make x. All right, so 2 pi x and the height, which is the function, which is 2x minus x squared. Then the thickness, which is dx, right? Okay. Now, we do distribute 2 pi out there. Okay, so we have distribute we get 2x squared minus x to the third power dx. All right. So let's do this one. Two pi integrate respect to x. What do you get?
Okay, we have 2 divided by 3
Very good.
x to the third minus
X to the power of 4 over 4.
first divided by 4.
Thank you very much. So we do evaluate from 0 to 2. Now, can you please calculate 2/3, 2 cube minus 2 to the 4th power over 4. Luckily, other one is 0. Okay, can you please calculate? What do you have?
I got the answer, but it looks weird right now. 1
for the-
divided by 12, x to the third, multiplied by, never mind, I need some time.
Okay, lady, can you please give it to me?
I got, for the first part, I got 4 pi to the power of 3 over 3.
Okay, can you please give it to me answer?
Oh, the complete answer?
A complete answer, yes, please.
Oh, 8 pi over 3.
Oh, 8 pi over 3? Wow, excellent. So this is what you got too? Okay, good. So in the chat, direct message, yes. Thank you so much. I cannot call your name. Thank you very much for participating, everyone, all the time. So 8 pi over 3, right? Very good. Okay, nothing hard, right? So as long as understand how creative thickness of a cylindrical shell, right? So easy. Okay. Now, oh, we did revolving y-axis, right? Now, what if we do revolving x-axis, right? Then they creating thickness in y interval, right? Okay, so think opposite way, right? So method. Cylindrical shell. And x-axis. Okay, so around the x-axis means rotating x-axis, right? Okay, so g of y, they said let g of y is continuous and non-negative. And they have the interval, which is y equal to c and y equal to d. Now they have the rotating about the x-axis. Oops. The volume of the solid of revolution formed by Q around x-axis by the volume from C to D, 2 pi y and g over y and dy. Okay, so rotating. So x-axis means creating, generating the thickness. Point. No space. All right, this means we do integrate with respect to y, all right? Okay, then here again, this is average of radius, right? So average of radius. And so we have thickness. Okay, so this is the height as well, right? But in y interval. Yeah. Okay. All right. So let us do this one. Can you please read x-axis? Okay, so look, reviving x-axis at this time, right? Then they're generating cylindrical shell in y interval, right? So this is axis. Thickness. Y interval means that we'll integrate respect y, right? Okay, now look, everything we write down in terms of y, right? So in this case, the volume, we have y. So from 0 to 4, I can see that here, and also they gave us, right? From 0 to 4. Okay. So interval from 0 to 4, we can see that. Okay. Now 2 pi. We write down y, and then we write down the function, which is in this case the 2 square root of y then thickness, which is dy. Okay, now with the multiply distribute, so we have 4 pi. Now we have y times y 1/2, which is 3
It's
over 2, right?
y to the 3 over 2.
Excellent. So we get y to the 3 over 2. Okay. Now we have what? Can you integrate this one?
Yes.
A over 5 pi y 5 over 2 power.
Okay, good. So we do evaluate from 0 to 4. And we have
2, 5,
so
6.
8
pi
pi over
over
5. And then we do 4 to the 5 over 2, 0. Now, can you please calculate?
256 over 5 pi.
Okay, thank you very much. Do you guys get the same answer with him?
I have the same.
Yes.
Very good. Thank you very much. All right. Now, so this is a little bit special because we had only one function so far. Now we have two functions. Okay, so we have two functions. How do we do? So we have a little bit different strategy for this one. Okay, please read this one. Okay, so look, we have a function, which is, we say that the bounded above by this graph, which is the square root of x, and below by the 1 over x, right? So that is the square root of x and below by this one. And they say that from 1 to 4, and then revolving about the y-axis. So this one revolving there and create the thickness, right, in x interval, right? Yes. So we can see that there's a much better graph. Yeah. Okay. So let me write down. Think generating thickness. Now we're gonna say that what is called integrate respect the x, right? What is called all right, but then in this case we have two functions. Then we can use the concept of the area between two curves, right? Okay, we can use the concept, which is top minus the bottom, right? We talk about the height, right? If we have x-axis, y minus the left function, right? So let us finish this one. Okay, So we have a volume. And let's see from 1 to 4, they gives us now 2 pi r, which is the x in this case. Okay. Now, normally we have just only function, right? But then we have two functions. So we do that from f of x, which is indicated that in this case is top and bottom, which is 0x, right? Between 1 to 4. Between 1 to 4, we're looking at only this part, right? Can you see that? This is the top, this is the bottom. Okay. Yeah. If you want to know about which one is top, bottom by hand, you can pick any number, not bounded point. Okay. Then which one is the top, which one is the bottom? You notice that easily. Okay. All right. So we do that. Dx. Okay. All right. Then 1 to 4, 2 pi x. All right. So the top one, which is square root of x, bottom one, which is 1 over x, right? Now we do distribute. So what do we have? We have a 2 pi. We have 1/2 we had experienced earlier, so we get 3 over 2 minus 1, then more easier. Okay. Your turn. Integrate, what do you get?
Seven.
Oh, x to the
Oh.
So x to the fifth over 2 times 2 over 5,
okay, good.
and then minus x.
Very good. So we do evaluate from 1 to 4. Now, can you please calculate 2 pi 2 over 5 x, which is 4 to the 5 over 2 minus x. Oh, it's a lot. Minus 2/5, and this is negative 1. Now,
I got 94 pi over 5.
wow, she got that really quick. Does anyone has the same answer? Wow, you guys are excellent today. Wow. Okay. So today's lecture is done. Thank you for coming. Excellent today.